Hello and welcome everybody to Game Changer, the podcast by TWS Partners. My name is Florian.
And this is Simon.
And in this podcast, we are exploring applications of game theory in business and everyday life. Our guest today is Michael Ostrovsky. He's professor of economics at the Stanford Graduate School of Business. His research is in the areas of game theory, market design, industrial organization, auctions, and matching. He is also a co-founder and chief scientist of the company TopSort, which provides auction-based advertising infrastructure for online marketplaces. We will discuss with him today how we all are starting tens to hundreds of auctions a day just by searching something via Google, and the journey how auctions evolved as a central element of revenue generation on the internet. Michael, many thanks for joining us on the podcast today.
Glad to be here. Thanks for inviting me.
Michael, today's topic, a brief history of auctions for online advertising, is actually very strongly linked to your own professional and academic journey. Could you therefore, maybe as an introduction, give us a bit of a background on yourself? How did you come to study and apply game theory?
Sure. I had a mathematical background, and then as a math undergraduate student at Stanford, I started looking around at, areas where I can apply math to the real world. And a couple of classes that I took that I thought were really interesting. One was game theory that Steve Tadelis was teaching. And the other was a course by Paul Milgram, who was actually teaching a course called Theory of the Firm, but this was late 1990s. And he just finished running the first FCC auctions a couple of years earlier. So he was very excited about that. And he talked about that for a couple of classes, and I thought this topic was really fascinating. The idea that you can take all of these electromagnetic spectrum and slice and dice it and have this clever auction to sell them off was a really fascinating application of kind of some mathematical principles I was learning and game theoretical principles I was learning in some other areas, and also combining that with real world intuition. So I thought that was really interesting. And so, when I went to grad school in economics, I actually wasn't completely set on doing market design. I knew about it, of course. I was excited about it, but I wanted to explore a whole bunch of different things. But eventually I did converge back to this topic. And my dissertation was actually on a slightly different area of market design. It was on matching, and specifically matching in supply chains. And my advisor was L. Roth. But along the way, I was kind of keeping an eye on interesting developments out there. And I was chatting with my classmate, Ben Edelman, who was also doing a PhD at Harvard at the time, a couple of years behind me. And we both noticed these new interesting auctions that were being conducted on Yahoo, and they were just starting on Google, where when you search for a specific term, let's say, car insurance or plane tickets, advertisers could target these specific keywords, and they can advertise specifically and precisely to people who are searching for those things. And we just decided that it's worth looking into these auctions and trying to understand how they worked and what their properties were. And that was kind of the beginning of my journey, that then it turned into a whole long research agenda that I'm actually still working on to this day.
It sounds very interesting, and a lot of names that are familiar to economists and game theorists. And I think it's also great that you joined this topic when it was really coming up. So let's move directly into that topic, auctions for online advertising. This might sound a bit niche to some people, but actually, it is at the core of many business models on the internet. So could you give us a brief introduction on that topic? Why is it important? Why should we know about this?
Sure. I mean, if many reasons why you may want to know about this. One is that it's one of the coolest and largest applications of game theory and auction theory out there in the wild. Also, it's something that everyone encounters every day, right? Every time you go on Google or on Facebook or on Amazon or anywhere else on the internet, you are triggering either one or possibly multiple auctions among advertisers who are competing for your attention.
And I guess many people are not even aware about this, right?
That's probably the case. I'm certainly aware of this, but I'm sure. I'm sure. I'll give some examples later of things that people are maybe not necessarily aware of. Like lots of people are aware of Google and that Google is showing ads on the same on Facebook, but there are some other that are maybe a bit more surprising. And if you look at companies like Google or Facebook, the revenues from these advertising auctions that they conduct are still, the vast majority of their revenues and profits. And Apple is now running these types of auctions in their App Store. Amazon is now running these types of auctions. I'll come back to them a bit later when we talk about new uses of these types of auctions. And Microsoft is running them. So if you look at the top 5 largest tech companies out there, they're all running these types of auctions and making billions of dollars from them, and impacting what you see, what you buy, what kind of medium you consume. And so one thing I actually do want to maybe highlight is that's something that people may not necessarily think about right away, is there are actually 2 types of auctions for advertising online that I like to put in separate buckets. One is the kind that Facebook is running, and that's more traditional in the sense that you don't go on Facebook to buy pants or jeans or sneakers. You go there to check how your friends are doing. But then while they have your attention, they also show you these things that you might be interested in buying, right? It's the same as when you buy a newspaper, New York Times. One way they monetize it is on the side they have all these advertisements that are not directly relevant to what you're doing right now. And then that's a large type of advertising, large part of advertising online, sort of known as display advertising. And then there is a second type, which is what Google is running, which is what Amazon is running, where you go on the website and you tell them what you're looking for, right? You say, look, I'm looking for jeans, I'm looking for sneakers. And then they show you some organic results and also show some ads for these specific types of goods that you're looking for. So both types of advertising are very large online. We're talking hundreds of billions of dollars of revenue per year, but I think they're sort of qualitatively different because they're based on somewhat different principles, which is not surprising, right? In the first case, you're trying to guess what people might be interested in. In the second case, they actually tell you what they're interested in, and your job is just to find the most relevant ad for them.
And I think now we want to talk probably more about the latter one. Namely, let's take Google as one of these examples. Someone puts in a search word, and the companies that want to advertise for that search word buy the search word to put their advertisement against it. And what we now want to explore in the next discussions is, why is that actually a non-trivial problem? Because if you're not familiar with the topic at all, you could think, well, someone puts in a search word, I bid whatever amount of money for that, and then I can place my ad, and whoever bids the most places the ad. And we just want to understand from your knowledge why this is difficult, and maybe starting the discussion with doing it a bit chronologically.
Yep.
How did they do it in the very first place? How did they approach it in the very beginning, and why was it difficult? And if you can just share some of the historical background.
Yeah, absolutely. No, absolutely. And that's actually also where my research on these topics started. So my very first paper with Ben Edelman actually documented issues with exactly the format that you just brought up. And the idea of what you just said, and the idea of this targeted type of online advertising where advertisers bid on specific keywords, goes back to around 1997 to the company called GoTo, which was then renamed into Overture and eventually purchased by Yahoo. And they were the real innovators. They came up with this brilliant idea, and it was actually several different components that came together to make things work. So the first innovation was just the idea that instead of just showing banner ads and trying to, get someone interested, you say, no, we're going to show ads when people search for stuff, and we're going to show the ads for the things they're searching. And so to make this work, we're going to have this whole idea of keyword advertising, right? So that's innovation number one. You specify, how much you want to bid on a particular keyword. The second innovation that they introduced was that the bidding language was bidding per click. Before that, you would, an advertiser would pay for, how long their ad would be shown on the website or how many people would see it. And now they said, no, what we're really delivering are clicks. So, you will pay for clicks. The third part that was also very important was that instead of having to call up the sales department of the search engine or talk to a human, you could bid in a completely automated fashion, right? So they, go to build this user interface for the advertisers where they can, on their own, with no external help, they can log in and manage their campaigns completely on their own. And even they don't necessarily have to log in. They could just do it programmatically, right? They could write their own programs that would reach the bidding API and change the bids in real time. And now the way it would work is, let's say, suppose the keyword is jeans, and a whole bunch of jeans manufacturers say, no, we're interested in bidding. So they all submit their bids for the specific ads, for the specific text, for what they want to advertise. And then these bids stay in the system, right? So they will participate in a whole bunch of different auctions. If you have 1,000 auctions per day, they will all participate in all of them. And exactly as you said, their initial logic was very simple. They said, look, if someone is willing to pay $3 per click and someone is willing to pay $2 per click, we'll show the $3 bidder at the top and the $2 bidder right below them, right? We're going to sort all the ads in the descending order of bids. And then if someone clicks, well, they told us they're willing to pay $3, we're going to charge them $3 if someone clicks on their ad. And if they told us they're willing to pay $2, we'll charge them $2. And so that was the design. That was the original design. And it's very logical. And again, it's really, it was really quite innovative for the time. Because the whole internet advertising started just in 1994. That's when the first banner ads showed up. And already, 3 years later, they came up with this very elaborate system.
And the incentive to place a high bid was to be shown as the top. And the assumption is the higher your rank where you're shown, the larger the probability that you'd be clicked. And probably there would also be the restriction from the provider, Yahoo or Google or whoever, that they'd only show, I don't know, the top 3 or top 5 or whatever amount.
Yeah, absolutely. Yeah, so I should have mentioned that. Clearly, yeah, the main reason why you want to be shown higher up, why you want to win higher in this auction, is that the higher up you're shown, the more clicks you're going to get, and that's empirically confirmed pretty much on every platform I'm aware of. What also makes this auction special, as you highlighted, and that will be part of the issue that I'll get to in a moment, is that you're selling multiple positions, right? It's kind of this interesting auction where your bidding language, you only bid per click, you specify how much you're willing to pay per click, but that applies to the whole profile of positions. And you may win the top slot, you may win the second slot, the third slot. It's not like there is one winner and everyone else loses. There are multiple winners. They just get different quality objects when they win. And the quality is just the number of clicks they're going to get.
So then you've already mentioned what happened. Why was it not that clever?
Yes. All right. So it's a fantastic design, and well, overall fantastic innovation. But it turned out that there was a very basic game theoretic flaw in it. And this is a game theory podcast, so I think for your listeners it will be really fun to see a very direct connection between game theory and the real world, or as direct as it gets. And I'll first say it in a very technical language. So in this game, in this bidding game, there does not exist a pure strategy Nash equilibrium. Okay, so let me now say it in plain English what this means and why it's a problem. So let me give you a very simple example. Suppose there are only two bidders, all right, and two advertisers, and there are two slots. Okay, very, very simple, very, very basic. And let's say, to make it even simpler, each bidder values each click at $10. All right, so as simple as it gets. Well, let's think about what would happen if I show up first. I'm going to bid 1 cent or whatever. And initially, and we'll talk about that as well, initially there were no reserve prices here, which in practical terms means that you can bid as low as 1 cent. Okay, you can bid 0, so you can bid 1 cent. And you don't want to bid more, because whenever you get a click, you pay your own bid. And guess what? You try to minimize the bids subject to winning. Well, now the second player shows up and says, well, my opponent is bidding 1 cent. I can either bid, also 1 cent, and then, it's a lottery, or maybe there's some priority rule, or I can just bid 2 cents and I'm going to win the top slot that makes quite a bit more in terms of clicks than the second slot. Okay, so the best response to the other bidder bidding 1 cent is to bid 2 cents. But then the first bidder says, wait a second, now I'm losing. And if I outbid this guy by 1 cent, if I raise my bid to 3 cents, now I'm going to be in the top slot. Okay, and so far that actually sounds like, if you think about how Sotheby's auction works, it kind of works like that, or Christie's, right? You bidders outbid each other. That part is okay, right? And so the question is, what happens as bids keep going up? Well, at some point, suppose when we get to $5, one of the bidders says, you know what, that's too high. I don't want to continue outbidding, and I no longer want the top slot. Now, precisely because there are two slots here, or more than one, this bidder doesn't drop out of the auction. He just settles for the second slot. And here's where the problem arises. Once he settles for the second slot, he says, well, I no longer want to bid $5, right? Like, why would I bid $5 that, we kind of reached and still get the second slot? If I'm settling for the second slot, I might as well bid 1 cent, right? There is no reason for me to continue this high bidding if I'm losing. Well, guess what? At that point, his opponent says, oh, he's bidding 1 cent for the second slot, so, I can get the top slot with 2 cents, and the whole cycle restarts, right? So going back to the formal statement, right, in this game, there is no profile, there is no profile of bids for these two players such that each one is a best response to the bid of the other, right? This game does not have a pure strategy Nash equilibrium. And remarkably, when we looked at the data, so this was my first paper with with Ben Edelman. We actually asked around. We were on a fishing expedition trying to understand sort of how these things work. We asked a bunch of companies for data, and at Yahoo, David Pennock, who was there actually since Overture days, was gracious enough to share data from 1,000 most important keywords with us. It was obviously anonymized and properly protected, but we could see the numerical data for the bids, and we saw exactly these very regular sawtooth patterns all over the place, exactly of the kind I described. And at first we were surprised that they're just so regular. Are there people sitting doing that? And then we realized, of course not. It's bidding robots, right? So you have these advertisers who say, look, I want to respond quickly, things change quickly, and so I'm going to build a robot that looks at the profile of bids by others and bids the best response. And because there is no Nash equilibrium, there is no stable profile of best response, you just have the cycling behavior. And in the paper we show a couple of illustrations of that, but it's it was all over in the data over the different periods. And so what's interesting about this, it's actually it was not a fatal flaw, right? This system worked for about 5 years and it was generating a lot of money. But what was interesting is the way that engineers noticed this and thought this as a problem was that this put a huge load on their servers, right? Because even though the fundamental underlying economics of these advertisers weren't changing nearly as fast, right? I mean, you may have, a sale one week or something else the other week, but, your optimal sort of value for these clicks doesn't, remains fairly stable over a long period of time. But instead, they try to submit their bids as quickly as possible because that's how they outbid the others and end up on top. And so, that was kind of the very original design. So it was really brilliant on a whole number of dimensions, but it had this pretty serious shortcoming, which led to the design eventually getting scrapped.
And as you said, probably as whenever you start with a new innovation, already the fact that they were doing that they had an auction and that they were auctioning off the places was an innovation and brought them huge revenues. But every first step then needs improvements. And after that realization, then there were changes done to the mechanism. And this is now the interesting part, that the logic was maintained in terms of auctioning off where you are sitting in the scheme, but the underlying auction mechanism behind that was changed, right? Can you, without now going into all the mathematical terms, but can you describe how the challenge was solved and what was changed?
Yeah, absolutely. And so as I said, GoTo came up with these in late 1990s, and then in early 2000s, Google decided to run similar auctions, but they had the benefit of hindsight. They had the benefit of learning from the problems of the earlier designs, the way it usually works. You iterate over time, and so they made two changes to this overture design. The first change was that instead of ranking advertisers purely based on their bids, they said, look, some advertisers are just inherently more relevant for the users than others, right? So if I, Mike Ostrovsky, go and bid on keyword car insurance, probably not many people will click on me, even if they show me at the top. But if a normal insurance company shows on the top, of course they're going to get a lot more clicks than me. And so they have this measure called clickability. How likely are you to get clicked if you're shown in a particular position? And so Google said, look, instead of ranking just purely based on bids, we're going to rank by some function of the bid and this quality score. And initially, the function was very simple. They would literally rank everyone by the product of the bid and this quality score, which was just the probability of a click. Over time, it became more complicated, so they no longer reveal exactly what goes into their quality score. But there are things like quality of the landing page, how long it takes to load, so a whole bunch of things. But the main change was that just moving away from ranking purely based on bids to ranking based on bids times some measure of the quality of the ad. So that was change number one. And change number two, which was, again, very game theoretically inspired. They said, look, instead of doing this previous format, which we call generalized first price auction, because you pay your own bid, they moved to the generalized second price auction, where instead of paying your own bid, you pay the bid of the person right below you. Okay, so more formally, because you have those click adjustments, clickability adjustments, you pay the smallest amount you would need to bid to win your current position. And so if you think about the examples that I gave you, where you have those two bidders and they sort of get to a particular amount and then stop, once my opponent drops his bid to 1 cent, I actually don't benefit from dropping mine to 2 cents because I'm going to pay my opponent's bid. And so this design turned out to be much more stable. Now, what's interesting about this generalized second price auction is that it was very much inspired by designs like Victory auction, which are what's known as incentive compatible, where it's optimal to bid your value truthfully. But in this particular case, in the generalized second price auction, it turns out that it's not optimal to bid your value truthfully. And I can give you a very simple example of that, and just to illustrate what the issue is. So suppose there are three positions now, okay, and three bidders, and the bidders' values are $10, $9.99, and 1 cent. Okay, it's deliberately a very very dramatic example. So if we all bid truthfully, then the $10 bidder ends up at the top, $9.99 ends up in the second position, 1 cent ends up in the third position. Okay, so that part is fine. But now put yourself in the shoes of the $10 bidder, right? If they bid truthfully, they get the top position, but their profit is only 1 cent per click because they have to pay almost their value. If, however, they say, you know what, I'll settle for a lower position, right? They'll drop their bid to, I don't know, $5, or you pick your favorite number between 1 cent and $9.99. Then they're going to get the second position. They're going to get slightly fewer clicks. And empirically, by the way, this kind of drop is about 30%. So for each slot you go down, a good rule of thumb is to say you keep 70% of the clicks as you move from position 1 to 2, 2 to 3, right? And so they're going to make this much higher profit. And so what's interesting about this design is, as long as you're staying in your own position, changing your bid by a little bit doesn't do you any good, right? And so you still pay the same amount as the bidder below you. But if you make a bigger change and you say, you know what, I'm willing to settle for a different position with a smaller number of clicks, you can actually be better off. So it's closer to being incentive compatible in the first price auction. So the way I like to think about this, in the first price auction, you're just asking for trouble, because there, whenever the bidders change their bids, they immediately see, positive reactions. Like you get this like reinforcement learning type behavior where you teach them that they should continue modifying their bids. Whereas in the generalized second price auction, you need kind of bigger jumps. And then, so my second paper, and this one was also with Ben Edelman and with Michael Schwartz, who at the time was an assistant professor at Harvard, and now he's a chief economist of Microsoft. We figured out the properties of these generalized second price auction. We figured out that you can actually characterize the equilibrium, what the bidding functions look like, where things will converge. And as we started presenting this paper and telling others about our results, Hal Varian, who at the time was working with Google, said, "Oh, it's awesome that you guys wrote this paper, because now I can release my own, which I wrote a bit earlier, but Google wouldn't let me publish it because they viewed it as a secret. But now that the secret is out, I can also talk about my paper." So sort of, those two papers, our paper and Hal's paper, sort of established the foundations for the properties of this generalized second price auction, which is, again, not incentive compatible. It's not optimal to bid truthfully, but at the same time, it does have very nice properties, and you can characterize the outcomes.
Just out of interest from an economist's point of view, because you said originally the motivation was to change from a first price original approach to the more generalized second price approach. The motivation was kind of an IT motivation to get the input more smoothly and not to have the loops of changing the prices so regularly. But now I'm wondering, from an economist point of view, did it also change revenues, or did it not affect revenues?
So I don't think there is a formal study on whether this changed revenues, because also, this was done by different companies. But in my first paper with Ben, we actually point out that in the generalized first price auction, you also get suboptimal revenues. And the reason for that is, think about just efficiency. Forget about revenue, think about efficiency, right? An efficient auction would always put the highest bidder at the top, the second highest valued person in the second place, etc. Now, when you have this continuous outbidding of bidders by each other, it's the fastest bidder who is usually on top. And then if bidders are all equally fast, if they all use the same technology, then, well, if there are three equally fast bidders, then you have the top valued bidder only being shown in the top slot 1/3 of the time. So it's clearly inefficient. And then we sort of do some back of the envelope calculations showing that it also impacted revenues negatively. So it's not just the IT reason, absolutely. And yes, and what's important is that in the generalized second price auction, and that's what my paper with Ben and Michael shows, and what Hal Varian's paper shows, you do get the same revenues, the same outcomes as what you would get if you ran sort of a full incentive compatible, theoretically beautiful Victory auction.
Wonderful. Okay. And that's why there's probably less incentive to change to that approach, because you can't prove they're going to make more money.
Yeah, so that's actually an excellent question, because after our papers came out, there was a very natural question. Well, maybe we should switch to the Vickrey-Clark-Groves mechanism, which is this theoretically beautiful mechanism. And in fact, there was a little bit of a movement in that direction. So the Russian search engine Yandex actually switched to the Vickrey-Clark-Groves mechanism. Facebook used it for their auctions. Google used it for some of their auctions for AdSense, not for their main line of business, but for for those ads you see on people's blogs when they try to guess what the right ads are given the context. So people have used VCG. Usually they used VCG in settings where the notion of the next highest slot is not that clear, or ads can be of different sizes when things get more complicated. And then just the basic idea, I'm going to charge the next highest bidder's bid, it just becomes even harder to interpret. Whereas the Vickrey auction kind of is this very big framework that allows you to make it operational even when the environment is more complicated. But going back to your question, yes, for Yahoo's main business and for Google's main business, they saw that this generalized second price auction design is working really well. Theoretically, it's not clear that they would actually make more money if they switched to something like the Vickrey auction. It would make life easier for the bidders. But if bidders have already paid the cost of learning how to bid in the generalized second price auction, it's not clear that you're actually making their life better by switching to something else. And so as of right now, and it's been almost 20 years now, right? So they launched their design in 2003. They're still running the generalized second price auction for their main AdWords product.
So and thanks for that explanation. It was wonderful. We ran like in 20 minutes through 20 years, but I think we had like the key events in the story. But now we've arrived in this chronological discussion at today's point, and obviously the things are going to further improve, and it's small adjustments. I assume Google is taking all the time anyways.
Of course, yes.
But what we wanted to discuss with you now in just a few seconds is you've now founded your own company looking at auction software and providing auction software. And because now we have arrived today and this is what you're now doing today, could you give us some background on what you're focusing in that software and what you're focusing with your own company?
Sure. Yes. So, when I wrote those papers, and these auctions were new, there were not that many people who knew stuff about that. So companies that were running these things were interested in collaborating, and so I started, consulting. And the first big consulting client was Yahoo, and we actually did a really fun project with them where we implemented reserve prices. So there was, Nobel Prize winning work by Roger Myerson, who figured out how to set optimal reserve prices. And up to that point, no one actually tried to take it seriously and apply it in practice. And this was a perfect setting to try it. So that was a really nice project that was very impactful, made Yahoo a bunch of money, showed that this theory is actually useful, and actually sort of more generally showed that economists can be very useful in this context, right? So that our toolbox, our game theoretic, auction theoretic toolbox is very applicable and very practical. And so, then after that, kind of the people who were working there at the time, they moved around to different companies. So they would call me up on various occasions and ask to help them with various auction-related projects. So I worked with LinkedIn, I worked with Pinterest, I spent a year at Google, and then a few years ago, I started noticing a few things. So first, I realized that I keep repeating the same things over and over again. There are some kind of best practices where it's like, it's like you do it right, and just start learning how to do it right. Second, I realized that it's much easier to build something correctly from the beginning than to try to modify something that was not done correctly. And then the latest development, which was really kind of critical, was that companies like Amazon started putting advertising on their websites using the same exact logic as Google. right? So and making a lot of money. And it actually took them some time to arrive at the right design. I actually gave a talk about the generalized second price auction at Amazon around 2007, so a long time ago. And they in that time they experimented with a whole bunch of different approaches, right? So they would try to do things like, on the page for TVs, they would have ads by installers of television sets, so they thought that would be relevant. But after a few iterations, what they arrived at, which exposed, it seems very simple, but of course, lots of great things seem simple exposed. They converge to just advertising the products that are already listed on Amazon's website. So going back to where I started, if you search for jeans on Amazon, you're going to get ads for jeans that are already sold, are already products on Amazon. And sometimes you even get an ad for a pair of jeans, and then the top organic result is exactly the same. So you will have cases like this, and that exploded. So what most people don't realize is that by now advertising on Amazon is their most profitable division. Right, so it used to be AWS was kind of the largest, most profitable, and now my understanding is advertising just dominates that, and their estimates are that they make about $30 billion a year from advertising. Now, if you think about that, so that's great for them. So where does my company come in? If you think about that, then the fact that they have this huge revenue stream from ads allows them to lower their prices on other products, right? If they break even on those jeans or on everything else, they still make tons of money from ads. So that's still a wonderful business model for them. And if you're a retailer trying to compete with Amazon and you don't have such a source of revenue, you're kind of screwed, because either you match their prices, well, then you don't make any profit, you go out of business, or you set prices higher than Amazon's prices, well, then guess what? No, people are not going to buy from you, they're all going to go to Amazon. So you're really in this no-win situation. And so kind of the insight was that basically everyone will have to have similar systems, similar advertising systems. And then more generally, any marketplace or any listing service where people are searching for something and the search results are interested in being shown higher up is a good fit for these types of ad auctions, right? So the number of places where these types of sponsored listings show up has expanded dramatically. So in fact, when I was at Google, 2013, 2014, I was sort of advocating for doing the same type of ads in Google Play Store, right, for apps. I was telling them, look, you have this search for apps in the Play Store. It's a wonderful place to allow developers to promote their products, and now they do that. If you think about something like Uber Eats, same thing. It used to be just a listing service for restaurants. Now when you search for a restaurant, you see ads there as well. Now all of these companies, going back to TopSort, to my company, all of these companies that I just mentioned, they're huge, right? They have huge resources. They have, they can hire, dozens of economists, dozens of statisticians, software engineers, you name it, and build these auction platforms, which are quite elaborate. There's a lot of moving parts in those systems. Now, if once you go to a slightly smaller set of companies, those companies of smaller size, or companies that don't want to spend years on this and want to deploy these things fast, right? They just want to take an off-the-shelf solution. It's much harder for them, and so that's where TopSort comes in. We said, look, we're going to build this right from the start. Learning from all the mistakes others have done. With the benefit of hindsight of 20 years worth of mistakes, we'll avoid them. And now instead of having to go and get a whole team and build your own auction engine, you can just
call you.
Yeah, call up. Exactly.
You can just call you.
Exactly. And in fact, we're not quite there yet, but we will be there soon, where they don't even need to call us. We have our APIs are published, so they can just take those APIs and deploy them on their websites. And yeah, so that's the idea of the company. sort of, if you think what AWS did for storage, right? It used to be the case that all the companies have to invest in, database engineers and storage systems and all of that. And now they say, you know what, I'll just sign up with, AWS or Microsoft Azure, and that's it. All my headaches are gone. I just use an off-the-shelf solution. So we're building the same thing for this, advertising auction infrastructure.
Michael, that was truly amazing. We want to thank you a lot for participating, for telling us that entire story of how relevant auctions are, and not just auctions, how relevant auction design is and how much it matters. It was truly an amazing episode, and it was great to have you as an expert who's been on the journey from day one. So thank you so much for participating in this podcast.
Sure. Thank you so much for inviting me.
We were talking to Michael Ostrovsky. He is professor of economics at the Stanford Graduate School of Business. We would love to hear your comments, feedback, or questions. Just send us an email to gamechanger@tws-partners.com. If you have enjoyed this episode, please subscribe to our podcast or leave a review or rating using Apple Podcasts or your favorite podcast app. Many thanks for listening, and we hope you also tune in for the next episode of Game Changer.